Hey, so we got this problem and it says simplify the expression the cube root of x to the 19th. All right. So we have that it's a property of square roots that if we have the cth root of a to the b, this is a to the b over c. All right. So I'm going to use that here and I'm going to rewrite this as x to the 19 over 3. All right. So that's going to give me x to the 18 over 3 times x to the 1 over 3, because it's another property of exponents that if we have a to the b times a to the c, we get a to the b plus c. All right, so instead, I kind of use this backwards. I saw that 19 is 18 plus 1. So that's how I was able to break this 19 into 18 over 3 plus 1 over 3. And then I just split it into 2 here. And the reason I did that is because this 18 over 3 will reduce. It'll reduce 18 divided by 3 is 6. So we get x to the 6th times x to the 1/3. And then we can rewrite this again using this first property right here. We can rewrite this again as x to the 6th on the cube root of x to the 1. And then this would be my final answer. All right. Another way we could have gone about it to kind of use some other properties of square roots, what we could have done is started with the cube root of x to the 19th. We could have grouped all of these x to the 19 terms. We could have factored it by x cubed. So what we could have done is keep everything under the cube root, and we would have x cubed times x cubed times x cubed times x cubed times x cubed. Right, so this should add up to 19. 3 plus 3 is 6. 6 plus 3 is 9. 9 plus 3 is 12. 12 plus 3 is 15. 15 plus 3 is 18. 18 plus 1 is 19. So we used this property right here that I'm kind of squiggling. We used that one backwards again, but instead of breaking it up like we did before, we broke it up into threes, because another property of square roots is if we have like square root of b times c, this is the square root of b times the square root of c. So we could use that property and break up all of these cube roots into cube root of x cubed times cube root of x cubed times cube root of x cubed. We're going to have 6 of these. Kind of running out of room here, but we have 6 cube roots of x cubed and 1 cube root of should be x to the 1. All right, we just split up our square root, our cube root, into 7 cube roots. And then another property of square roots is that the cube root, or if we have the cth root of a to the c, this is a. The cth root and the power of c kind of cancel each other out, and we're left with whatever is being raised to the c power. So for our case, we have x cubed, and we're taking the cube root of that, so we're just left with x's. So we would have x times x times x times x times x times x for these 6 terms here, 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 here. And then we still have that last term, which is the cube root of x to the 1. Right, so then all of these x's we can combine as x to the 6th on the cube root of x to the 1. We get the same answer. It's just kind of like another way to do it if you wanted to like break up the x to the 19 into all of its different factors. Either way works. It's whichever way makes more sense to you.